This discussion is a continuation of solving translational equilibrium problems, and we are discussing translational equilibrium problems involving three forces. So I have already discussed with you how to solve translational equilibrium problems with two forces involved, and just the same, there are two formulas involved in solving translational equilibrium. Summation of all the forces in the x-axis is equals to 0, and summation of all the forces acting in the y-axis is equal to 0 in order for this object to be in its balanced state. So before, I have already discussed to you how to solve a load suspended involving two forces. So the tension force is an upward force and the weight is a downward force. We are done with this as our first example, followed by another example. This is the second problem. Now we will be discussing another problem which involves angles. So our problem is a 20 Newton signboard is hung along the corridor. Find the tension in the wire that holds it when it produces an angle of 60 degrees as shown in the illustration. So as per the illustration, this is the signboard and there are two wires holding it. So it creates a 60 degrees angle on both sides. Looking at the diagram, we can see in here that there are three forces involved acting together so that this signboard is in its balanced state. For our first wire, it exerts a tension force as it holds the signboard, and then tension 2 is for the second wire as it holds the signboard, and another third force here is the weight of the signboard. Let me remind you that the x-axis, this is the x-axis and this is the y-axis. So our first wire exerts a tension force both on the x and y-axis because our tension wire here is at the middle. Same holds true with our second wire, which exerts an extra force on the x-axis and a force on the y-axis. So if we are going to write the given in our diagram, there are three forces, T1, T2, and W, which is the weight. And under T1, as I have said, T1 gets a value for the x-axis because it exerts a force on the x-axis. So the value for T1x here is negative T1 cosine 60 degrees. Why negative? Because, as I have said, anything that goes to the left gets a negative sign, anything that goes to the right gets a positive sign. Anything that goes up gets a positive sign. Anything that goes down gets a negative sign. So since our wire 1 is towards the left, it gets a negative T1 cosine 60 degrees. Why cosine? Because cosine is the angle reference for x-axis, and sine is an angle reference for y-axis. So all the forces acting on the T1 is both T1x and T1y. For T1y, the value for T1y is T1 sine 60 degrees. So T1y here, T1x here. So T1x 60 degrees, that is negative. T1y positive, sine 60 degrees. Our next tension here is T2. The T2x value for T2x is T2 cosine 60 degrees. T2 cosine 60 degrees, positive because it is towards the right side. T2y gets a value of T2 sine 60 degrees. So T2 sine 60 degrees. Again, positive because it is an upward force. For the third force, we have the weight, Wx. We can see that there is no weight acting on the x-axis, so we have 0. Wy is equals to negative 20 newtons because it is a downward force, it gets a negative sign. Applying all of this in the formula, summation of all the forces in the x-axis is equals to 0. So when we say summation, we get all the forces acting on the x-axis. We have T1x plus T2x plus Wx. So all of these x's should be placed in 1 and get the sum of it. So we get in here T1x plus T2x plus Wx is equals to 0. Now, what is the value of T1x? It is negative T1 cosine 60 degrees. What is the value of T2x? We have T2 cosine 60 degrees. What is the value of our Wx? It's 0. So, negative T1 cosine 60 degrees plus T2 cosine 60 degrees plus 0 is equals to 0. What is the value of cosine 60 degrees? We have negative T1 times 0.5 plus T2, the value of cosine 60 degrees, just the same, 0.5 plus 0 is equals to 0. So since we have a negative sign here, we transpose this at the other side, so it turns out to be positive. It will become positive. So what is left in this side is T2 times 0.5 plus 0 is equals to positive T1 times 0.5. Now going further, so we add this one, T2 times 0.5 plus 0 is T2 times 0.5 is equals to T1 times 0.5. Divide 0.5 on both sides, so we get to cancel this one. The value of T2 is equals to T1 times 0.5 times 0.5 is 1. So the value of our T2 is T1 times 1, or T1, just the same. We go and solve for the value of our x. Summation of all the forces in the y-axis is equals to 0. So we get again the value of all the forces acting on the y-axis. We have T1y plus T2y plus Wy is equals to 0. So the value of T1y is T1 sine 60 plus T2 sine 60 degrees because that's the value of T2y plus negative 20 newtons, that's the value of our Wy, is equals to 0. So in finality, T1 sine 60 degrees plus T2 sine 60 degrees plus negative 20 newtons is equals to 0. So what is the value of sine 60 degrees? So we have 0.866 T1 times 0.866 plus T2 times the value of sine 60, which is 0.866 plus negative 20 newtons is equals to 0. So if you will notice, we cannot add T1 with T2 because they are of different subscript. So we need to get the value of T2 here. T1 times 0.866 plus the value of T2, that is our value of T2, is T1 times 1. So T1 times 1 is equals to 1 times 0.866 plus negative 20 newtons is equals to 0. So we copy T1 times 0.866 plus T1 already. T1 times 1 is T1 times 0.866 is equals to, we transpose negative 20 here to the other side, so it becomes positive 20. So since they have the same subscripts already, so we can add. So T1 0.866 plus T1 0.866, it becomes T1 1.732 is equals to 20 newtons. Now divide both sides with 1.732. We cancel this one, it becomes T1. So 20 divided by 1.732, we have 11.55 newtons. This is the value of force that is applied or exerted in order for our signboard to be in a balanced state. So that is the value for wire number 1. So how about our T2? What is the value or the force that is exerted in our T2? So we get this one. So T2 is equals to T1 times 1. So we get the value of T1, which is 11.55. 11.55 Newton times 1 is 11.55 Newton. So it is balanced that the tension force on wire number 2 is the same as 11.55 Newton. It is concluded that if they have the same angles, then they have the same force exerted on the signboard.